Hello, my name is Marius and welcome to our project pitch. Before we get started, make sure that you have your mic turned off, that you have the volume adjusted accordingly, and that you put this video on full screen. You ready? Then let's go! For this collaboration project, Getinge asked us to think about the future of vital sign monitoring in hospital intensive care units, the so-called ICUs. So we, as a group, took on this interesting challenge and went deep into the world of intensive care medicine to come up with new solutions on how to monitor critical ill patients in this special environment.
Welcome, my name is Tim and this is our team room where we did most of the work during this collaboration. In intensive care treatment, one of the basic and most important vital signs to measure is the ECG, which we chose as our main focus area for this project. Currently, ECG monitoring looks very much like this. These 5 cables, also called leads, are connected to electrode stickers in specific locations on the patient's body. These sensors are connected to a monitoring station next to the patient's bed, where the ICU nurses can find important information about the heart rate and the general health status of the patient. ECG monitoring is carried out continuously throughout the whole journey of the patient in intensive care. It is on the patient's body, sometimes for weeks, it is unplugged, it is cleaned, and it's a big part of the ICU nurses' daily routines. All these cables mean a lot of effort for the healthcare professionals, who are constantly busy untangling and rearranging them. This current hardwired setup also affects the patient's comfort. It limits their ability to move and therefore negatively affects the recovery process. How we approached this project and how we found a better solution for ECG monitoring will now tell you my teammate Jacob down in the workshop.
Hi, my name is Jacob and welcome to the workshop. As you can see in front of me, we had a lot of ideas during this project, all based on insights we found in the research. For us, it was quite clear that we needed to get rid of this cable mess to provide the best ECG monitoring solution for the patients and the healthcare professionals. But coming up with great ideas and sketching them down on paper is one thing. So we quickly realized that we needed to work very hands-on in this project to create mechanisms both for cable setups and arrangements, all to figure out which one actually worked and which didn't.
But what's even more important, here at the UMI Hospital we had the chance to show our concepts to real healthcare professionals and let them test and evaluate our ideas. Checking back with their expertise, we could validate our ideas and adapt our concepts to their workflows in the intensive care environment. From all the ideas we presented them, they picked a clear favorite, which led us to our final concept direction. Do you remember this cable mess? Our concept replaces the current 5-cable ECG with a single wire solution, called the array. By reducing the amount of cables to a minimum and simplifying the workflow, we help to improve the user experience for patient and healthcare professionals. And yes, it's wireless.
This sensor array gets placed on the patient's body and feeds the monitored data wirelessly into the current system, so that it can be displayed next to all the other vital signs on the patient monitor. A small receiver plugged into the already existing setup enables this wireless data transfer on an encrypted protocol. The array itself consists of a head that houses the battery, the antenna and a satellite interface, and a single cable sensor array that can be arranged freely on the patient's body. This device is designed to sit on the human skin. Its minimalistic shape makes it not only easy to clean, it also simplifies daily routines for caretakers and declutters the patient's appearance. The attachment of this device follows global intensive care standards and even guides healthcare professionals during this routine. They start by simply placing the head in the shoulder area and attach the other leads on the remaining electrodes. The clip's scissor sliding mechanism helps to fix them in a gentle way without applying pressure to the skin or even hurting the patient. The cable length can be adjusted by sliding them into the designated holders. With a nicely arranged cable setup, the device provides more comfort for the patient and ensures an optimal fit for each body shape or size. As soon as all the leads are in place, they're transmitting the monitored data, all while sustaining the patient's ability to move freely, unhindered by cables. On the head of the device, sensor connection and the battery status can be checked. The battery can be exchanged easily while the setup remains placed on the patient's body. During cleaning or special treatment, nurses deattach the ECG array and place it in the charging dock, which is fixed next to the patient's bed. Here, the sensor can be stored when it's not in use and gets charged simultaneously.
So in this project, we designed an ECG monitoring setup of a new generation that can be implemented in the current practice of intensive care. Our solution helped to streamline the healthcare professional's workflow and offers more flexibility in movement for patients, all in order to speed up the recovery process. So if you would like to learn more about this project in detail, please join us later for our presentation.
Design.